Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. The work function of molybdenum is 4.22 electron volt. Part A. What is the threshold frequency for the photoelectric effect in molybdenum? Molybdenum. Okay, molybdenum. Part B. Will yellow light of wavelength 560 nanometer cause ejection of photoelectrons from molybdenum? Prove your answer. As usual, we go to before starting its solution in a formal manner. We will have to first go through a few snapshots which will provide a foundation regarding the solution of this problem. Okay. So, first snapshot includes various physical constants. We will use that physical constant which we will require. Okay. So, because this table has been taken into consideration several times in our previous problems, previous videos, so we will not give enough weightage to this snapshot, and we will move forward. Okay. Next snapshot is about momentum of a photon. Momentum of a photon P is equal to E over C, where E is photon energy and C is the speed of light in vacuum. This alternatively becomes equal to HF over C, where again C is the speed of light in vacuum, H is the Planck's constant, and F is the frequency. This alternatively becomes equal to Planck's constant H divided by wavelength lambda. Next snapshot is about photoelectric effect. Okay, this snapshot has also been taken several times, particularly during previous three problems, previous three videos which have been uploaded recently today. Okay. Next snapshot is about Greek alphabets. Okay. This has also been taken several times, particularly during last three three videos. Next is some detail about work function. This snapshot has also been included several times, particularly during last three videos which have been uploaded today. Okay. So now we are going to start our solution in a formal manner. We first come towards part A. Okay, we know that threshold wavelength is given as lambda t, where t is written as a subscript of lambda and t denotes threshold. Dear students, threshold or cutoff or longest or maximum. Okay, these terms almost convey similar sense. Okay, but similar sense does not mean exactly same. Okay, so in addition to similarity, difference also exists. Okay, similarity and difference both exist. However, here we are pointing out that threshold wavelength or threshold frequency and cutoff wavelength and cutoff frequency or longest wavelength and longest frequency or maximum wavelength and maximum frequency convey similar sense but not exactly same. Okay, anyhow, we do not emphasize more on this topic. Okay, threshold wavelength lambda t is equal to hc over phi. Phi is work function. This implies that from here, if we want to find out the value of work function phi, then phi will become equal to hc over lambda t. Okay, just rearrangement, and this alternatively becomes equal to h into ft, that is threshold frequency. Frequency and wavelength are reciprocally related with the involvement of c speed of light. That is to say, frequency is equal to speed of light divided by wavelength, and wavelength is equal to speed of light c divided by frequency. Okay, so this implies that from here, if we want to keep ft, that is threshold frequency, on one side, then threshold frequency ft will become equal to wavelength, equal to work function phi over h. Work function phi over h, over h. Now, dear students, value of work function phi is given in the statement, and value of Planck's constant h is given in the first snapshot, which was just a table of physical constants. Okay, it is further pointed out that in that table, value of Planck's constant h has been given in two different system of units. Okay, so out of those two different system of units, we have chosen one which is relevant within this atmosphere. Okay, so by putting both these values, one from the statement and one from the table, which is included in snapshot number 1, electron volt will be cancelled with electron volt, and we will be left with only 1 over second along with relevant numerical value. We know that 1 over second, that is second inverse, second raised to the power minus 1, is equal to hertz. Okay, hertz or second inverse is one and the same thing. Okay, unit of frequency is hertz, and it is equal to 1 over second. So after simplification, our threshold frequency ft becomes finally equal to 1.02 into 10 raised to the power 15 hertz. Okay, now we move forward and come to part B. We know that wavelength is equal to speed of light over frequency of oscillation. This implies that threshold wavelength lambda t is equal to c over threshold frequency ft. This implies that threshold frequency ft becomes equal to c over lambda t, threshold wavelength. Just we have interchanged both. Okay, now value of c speed of light is given in the table, which is included as a snapshot number 1 in this problem, and value of threshold wavelength is provided in the statement, which is 560 nanometer, and nano is equal to 10 raised to the power minus 9. So remaining is just simplification. Dear students, here meter will be cancelled with meter, and we will be left only with 1 over second along with the relevant numerical value, and we know that 1 over second or second inverse is equal to hertz, which is the unit of frequency. Okay, so our threshold frequency ft will become equal to 0.00535 into 10 raised to the power 17 hertz. Actually, the student said nano, that is 10 raised to the power minus 9 is in the denominator, and it will be shifted to a numerator, and then it will become 10 raised to the power plus 9. So 10 raised to the power plus 9 and 10 raised to the power plus 8 will become 10 raised to the power 17. And in the next step, to this extent, our answer is quite acceptable and correct. But just as a fashion or as a matter of discretion, we are converting 0.00535 into 5.35. Okay, by doing so, because we are shifting decimal 3 stages ahead, then our 10 raised to the power 17 will be reduced to 10 raised to the power 14. Okay, and hence our threshold frequency ft will become equal to 5.35 into 10 raised to the power 14 hertz. Now we come towards part B. We know that wavelength is equal to speed of light over frequency of oscillation. This implies that threshold wavelength lambda t is equal to c over threshold frequency ft. This implies that threshold frequency ft will become equal to c over threshold wavelength lambda t. Okay, what we have done, we have just interchanged lambda t and ft. Okay, now value of c has been taken from the table of physical constants, which is included as a snapshot number 1 in this problem, and value of threshold wavelength lambda t is provided in the statement, together with the explanation that nano stands for 10 raised to the power minus 9. Okay, so dear students, here perhaps this step has been repeated. Even if repeated, it is not a major mistake. Okay, yes, yes, a little portion of this problem has been repeated and it is not a blunder, it is a minor irregularity. Okay, so threshold frequency has become equal to 5.35 into 10 raised to the power 14 hertz. Now energy E is equal to HF. Here F is a threshold, so Ft, E is equal to HFT. Value of Planck's constant H has been given in the table, which has been included as snapshot number 1 in this problem. And value of Planck's constant H has been given in two different system of units. From those two different system of units, we have chosen one value of Planck's constant H, and value of Ft, that is threshold frequency, we have calculated in the above step, which is 5.35 into 10 raised to the power 14 hertz. Okay, so next, just simplification. Here, dear students, second and hertz will cancel each other, because hertz is equal to 1 over second. Okay, so second multiplied by hertz will become unity 1. Okay, so our energy E will become equal to 22.13 into 10 raised to the power minus 1 electron volt. In order to remove this 10 raised to the power minus 1, decimal will be shifted one step backward. So our answer will become E equal to 2.213 electron volt. And we know that work function for molybdenum, which is provided in this statement, is 4.22 electron volt, and we know that 4.22 electron volt is greater than E, 2.213 electron volt. Okay, this implies that answer is no. Okay, because energy which we have found is less than work function 4.22 electron volt, This suggests that answer is no. No. What does no mean? No, in order to explain the meaning of no, will yellow light of wavelength 560 nanometer cause ejection of photoelectrons from molybdenum? So here no will stand that yellow light of wavelength 560 nanometer will not cause ejection of photoelectrons from molybdenum. Okay, so this is the end of our problem. This was the significance of no. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.